All right, good morning, everyone. Sorry again, I couldn't be there. Told some of you last night, my son has been not feeling well, so should be back tomorrow. In terms of your quiz, we are not having your AT grade today, obviously. We will have it tomorrow, and just so that you know, it is reassessable. So I'm going to post a couple of things in the module, one being kind of a little graphic organizer to help you with determining how to work from squared things to area to volume and so forth. So I will be having that for you in the module. So we are going to be handing out your PC review. That should be at the door in the bin. If you didn't pick up that PC review, it's not going to be due till the 21st of March, so you have a couple weeks here to work on it. The progress check is going to be on Wednesday the 22nd and Thursday the 24th. So just so that you are aware of that. There is an optional homework assignment tonight to practice what we're going to be talking about today, which is density problems that involve area. Okay. I know the date says that this is March 2nd, but it is not March 2nd. Well, I guess it is March 2nd. I guess I changed that. Anyway, I guess it's March 1st today that I'm recording this, but all right. So what we're going to do here is we're going to estimate the area of the classroom, and then talk about the ratio of the number of people to the area of the classroom, and then what does this ratio represent? Okay. So first thing that we have to do in order to calculate the area of the classroom is to kind of try and figure out length times width. And if you look on the tiles around you on the floor, each of the tiles that are on the floor are actually 1x1 tiles. So you could go ahead and count the tiles across the room. Unfortunately, I do not have memorized the number of tiles that go across my room. However, if I had to estimate, I think that probably the room is, let's say it's 21 tiles across by 24 tiles across. And again, I'm completely estimating this. And that would be feet. So 21 feet for 24 and 21 tiles and 24 feet for 24 tiles. And again, I know the room is not perfectly square. You're probably looking around going, oh, there's corners that are taken out. Yes, that would be an irregular area. However, we're just going to kind of assume that we have a rectangular classroom, and we'll have 21 by 24 feet. So we're going to go ahead and multiply then 21 times 24. And when we do that, 21 times 24, we get 504 feet squared. Okay. Now, probably in the classroom right now, if you include the sub in the room, and there are usually about 31 of you in class, let's assume somebody is absent. Let's just say there's 30 people right now in the classroom. I'm going to laugh if there are actually 30 people in the classroom today. We want to know the ratio of the number of people to the area. So we can write a ratio either as a fraction, or we can write it with a colon in between. But there are several ways that we can write that. Okay. We could also simplify it as a decimal. But this basically states that there are 30 people per 504 feet. Oops, I forgot my squared here. Feet squared. And if I simplify that, if I do 30 divided by 504, I get 0.059. 0.05, it's actually 595. And that would be people per square foot. Now that's kind of weird. How can you have 0.0595 people per square foot? Well, basically what that says is that there is enough room for, basically, I guess you could say, a 500th of a person for each square foot. So each person would basically have probably about, what is that? 100 divided by 5? Be about 20 square foot per person, if you want to put it that way. So if I reverse the fraction, okay, and I did 504 over 30, that would tell me then how much I get per person. So if I did 504 divided by 30, I get, a little bit less than 20, 16.8. And that would be feet squared per person. So this is kind of reversing the ratio of doing people to the area. Okay. Now, what we're going to talk about today is what we call population density. Okay. So we're going to talk about how many people can fit into a space, basically. And the way that we do that is we take population and we divide it by land area, and that gives us our population density. So, for example, in the United States, there are approximately, and this is a very old number, I believe, probably like, oh wait, it does has the year on here. This was in 2010, so this was about 13 years ago. They only do a census every 10 years, so this page in this curriculum was written probably about 4 or 5 years ago, maybe even 6 now. So that's why it was written in the decade of 2010. Okay. So I have 308,745,538 people, and that is divided by the land area, which in this case is measured in square miles. And so I say 3,531,905.43, and that is the square miles, the official square miles of land in the United States. Okay. If I divide those two numbers, I find out that there are about, in 1 square mile in the United States, about 87 people. Okay. So 87 people in every square mile. Now, if you think about what a square mile is, square mile is like if you drive a mile, make a square out of it, and that's a square mile. Okay. So in your car, if you drive 1 mile, say that this is 1 mile, a square mile would be if you made a square out of that. And in that 1 square mile, there are about 87.4 people. Okay. Now that could be dense. I mean, think about how many houses you would have to fit into that. And that's an average, right? So that's in the United States. So there are actually places in the United States that are much more dense than 87 people per square mile. Okay. So what you're going to do is, this is on page 71. You're going to go ahead and look through this table, and you are going to divide and find the population density, and then answer the 6 questions that you see on the page or in the video. Okay. So again, you're going to take and divide the population by the land area. So just kind of remember that. You really do have to pay attention to your labels. It just so happens that I am dividing these in order, but you do have to kind of be careful about that. So the first one's already done for you, and then I'm going to divide 710,231 divided by 570,640. So you should have a calculator, and you're going to go ahead and do those. Okay. So if you're watching this video as a class, the sub can pause it. If you're watching this video on your own, it's on the honor system. Okay. All right. So here's what you should have gotten when you divided all of those numbers. So which have the highest population density? So we're looking at the most dense places, not, okay, I know exactly what Asir is thinking right now. He's thinking, Mrs. Conway, you're calling people dense? No, I'm not calling people dense in terms of their mental capacity. I am saying dense in terms of their land area. So, or how many people there are per square mile in the United States. So if I look down through this list, I see that there are some pretty densely populated places. So we have the District of Columbia, we have New Jersey, that's kind of pretty densely populated. And I think, let's see, you guys can probably find this a lot quicker than I can right now. But I think that it's 839. I think that it's 839 is going to be your next one. So, which is kind of surprising. Massachusetts, New Jersey, and District of Columbia. Okay. Now, I know a lot of you are probably thinking, well, Mrs. Conway, why isn't it New York? Well, remember, we're not talking about just New York City. New York State is a pretty big state. And so a lot of people in New York are just centered right there in the city. So Manhattan is probably a lot more densely populated than District of Columbia even. But that is not a state per se. Even I know District of Columbia is not technically a state, but we do consider it kind of a significant place in the United States because it's our nation's capital. So we have DC, we have Massachusetts, and we have New Jersey. Okay. Now the lowest population density, surprising or not, we have Alaska. There's only one person per square mile in Alaska. And if you look down at the land mass of all of the states that we at least have listed here, it is the largest state. I think it's actually the largest state in the United States. Alaska. So I think that is the case. So it's the largest state and not a lot of people live there because it's so cold and there's not a lot of inhabitable space in Alaska. So that's why there's only one person. One person gets a whole square mile in Alaska. We also kind of see down here, we have West Virginia. Could be surprising. Depends. Again, it's not a popular state to live in. And Texas, again, Texas is so big and you might be like, well, there's lots of big cities in Texas. Yes, there are. But Texas has a lot of land. They're about half the size of Alaska. And they fit about 96 people per square. So we have Alaska, we have Texas, and we have West Virginia. Okay. Did the states with the highest land area have the highest population density? Why or why not? And that was a definite no. We saw that Alaska had the highest land area, but it actually had the lowest population density because there's not a lot of people that inhabit it. So again, there's lots of reasons you could list for numbers 1 and 2. Maryland's population density is 594.8. Do you believe that this is actually the case? Why or why not? And really what that's getting to is that's an average, right? So some places in Maryland probably have a lot more people than that. But some places like where I live in Frederick, there's not that, we actually probably only have, in our square mile, we probably only have maybe, 20 people that live in a square mile of where we live. So it can vary throughout the state, and that's why it's just an average. All right. So that's population density. It's a lot of talk about just basically dividing population by land area. So you can kind of see what the difference is with population density. So if I look at a high school hallway, when students get out of class, this is a very dense population. Just kidding. Densely populated. I need an LY. Densely, is that how you spell densely? Densely populated hallway. Okay. Whereas if we look at the hallway, maybe when the classes don't dismissed, when kids are supposed to be in class, or maybe it's close to the bell, this is less dense. Okay. Again, here, this was an example of Alaska. Remember, Alaska having one person per square mile. And you can see that, there's over 5 people that live. So you can kind of see the places that are most inhabitable in Alaska. And they're not that big. And there's only literally 5 people per square mile. And then you can see it gets less and less as you move throughout from those areas of Alaska. So this is what you basically, where you can see the most densely populated places in Alaska. This is Maryland. So again, oh, look at that. See, I'm up here in Frederick County. That's where I'm recording my video right now. So I'm up here, actually Frederick County is right here. We live like right about there in Maryland, okay? Olney is like right here in the middle of Montgomery. Oops, I marked the wrong county. That's not Montgomery County. Sorry about that. This is Montgomery County. That's Howard County. So in Montgomery County, we're kind of like right here. And actually, I think we're a little further north than that. It's going to bother me. Okay, I think we're like more like up here-ish, right? So you can see Montgomery County is much more densely populated. They have over 500 people per square mile. See, over 500. Whereas where I live up in Frederick County, average is 250 to 500. So yeah, you can kind of see that relationship. There's more populated places of Frederick, like downtown Frederick, and some places as you get closer to the smaller cities in Frederick. But all right, and this is the United States. So like I said, if we look at New York State, one of the examples we talked about was New York State. I mean, look, there are some like white areas of New York State, but look how densely populated it is down here in this little corner, but look at the rest of the state. There's not a whole lot of people there. And probably you could have like a social studies conversation. Your social studies teachers would love this. You know, why do we have so many people at the coasts and not so much in the center of the United States? And you know, a lot of it has to do with where people settled and the history of the United States and how, you know, we came over, you know, to settle in the 13 colonies, and then basically the gold rush in California. I mean, all of those things really contribute to where people settle and why they are more densely populated than others. So see, we not only tie in with science, but we tie in with social studies. You can tell your social studies teacher. All right, page 73, you want to open a dog walking business. They're considering east side and west side. You'll open the business wherever the density of dogs per home is greater than 0.35. So again, you want a lot of dogs, right? Because if you want a dog walking business, you want to have a lot of access and business that you can pull from. So according to town records, the 30 city block east side has 18 homes per block with 6 dogs per block. The dog population of a 30 city block has 4 dogs per block and 10 homes. Where, if anywhere, should you open a business? So I'm going to take this information and put it into your table. So the east side, again, has 18 homes per block, and they have 6 dogs per block. The 30 city block west side is 4 dogs per block. Goes here, and 10 homes. And what are the number of dogs per home? So they want you to do dogs, which is 6, divided by homes, which is 18. So 6 divided by 18, and then you're going to do 4 divided by 10. So go ahead and put those 2 numbers in your calculator and find where you should put your business. All right, so here's how it works out. We get 0.33 on the east side and 0.4 on the west side. So of course we should go ahead and establish our business on the west side of town. You're going to do the same thing on number 2, so go ahead and work that out. Take a second here to fill in the missing pieces. One little tip here is we're looking for the total shelf space in square feet. So we would do the number of books. So in the nonfiction, we have 528 books. And we are looking for the total shelf space, which is X, and that equals 0.805. So again, how would I solve this equation? I'd multiply both sides by X and then divide. So 528 equals 0.805X. And you're going to go ahead and divide by 0.805 and find your missing total shelf space. So pause this and then come back. All right, so this is what you should have found. And again, there's the work to get to those missing values. So we can say that for fiction books, they are the most densely populated books in the library, followed by nonfiction, and then reference. All right, this is page 74. So your thread count, or TPI, threads per inch, is a measure of the coarseness or fineness of fabric. And I'm just going to go right over here to the answer key because this one's a little bit tricky. It is the total number of vertical and horizontal threads in 1 square inch. So having nice poshy silky sheets is actually a direct result of the number of threads that you fit in a square inch. So when you go home tonight, you can be like, oh, my sheets have math. You probably won't do that, but that's okay. Again, thread count is determined by how many threads you have packed vertically and horizontally in 1 square inch. Okay. So suppose you have a bed sheet with a thread count of 60. This means there are 30 horizontal and 30 vertical threads. So as shown. So suppose you have a piece of cotton fabric that measures 36 by 44, and it has a total of 142,560 threads. So you'd have to put the number of threads, which is the 142,560, over the area. Remember, the bottom number is area. So to calculate the area of my actual total fabric, it would measure 1,584, that means that there are about 90 threads per square inch. Now, that means that if I want to know how many is on each side, that's the number of horizontal and vertical put together. So I have to split them in half, and I know then that I have 45. This would be a thread count of 90, and therefore I would have 45 threads going horizontally and vertically. Okay. All right. So last but not least, we have page 74. I'd like you to go ahead and determine the different population densities of each of these different high schools. And again, this was from a few years ago, so these populations could have changed. I'm trying to see if I know any of them offhand, and I don't think I do. So, all right, so you're going to do population divided by square miles, or square acres, basically, yards squared. All right, so pause the video. When you're done figuring out each of them, you then want to arrange them from least to greatest. So see, least is going to start here, greatest, so you're going to figure out each of these and then place them from least to greatest. And this is how it turns out. Poolesville is the least population, let me try that again. Poolesville is the least densely populated school, and Wooten is actually the most densely populated, and all the ones that fall in between. All right, guys, so if you would like to start working on your PC review, you can. However, you can also go ahead and study for your AT grade. Remember, that is reassessable. And I know some of you have been asking me about the quiz from last week. That is reassessable. And some of you still wanted to retake the irregular areas quiz, and you can also retake that. So we have quite a few reassessments here. Do not worry about getting them done before our interims go out Friday. You will still have an opportunity to work on some of those next week. I know I've been out a couple days this week, so let me know if you have questions. A few of you have been emailing me, and I appreciate that. So just keep your emails coming, and I have no problem helping out to answer those. All right, good luck, and hope you guys have a good rest of your day.